少々お待ちください。OK。
はい。じゃあ JJUG ナイトセミナー7月ですかねの JJUG ナイトセミナー始めたいと思います。今日オンラインにたくさん人がいて、今日オフラインですっごいもう大盛況で、もう席が全部埋まってね、信じられないぐらいの大盛況ぶりになってるんですが、本日は、VMware のオフィスをお借りしまして、ジョシュ・ロングに、こっち、
はい、そこへ。
そうなんだ。はい。ジョシュ・ロングさんに話してもらいたいと思いますので、ジョシュ、please.
Okay. So, see you, my friend.
はい、よろしくお願いします。
Thank you. All right. So, we're ready to go. Ready to rock and roll.
Okay.
All right. Let's see. Actually, make sure I have liquid. That's the one thing I need. All right, my friends. Good stuff. Let's get started. We don't have a lot of time. We have a lot of stuff to cover. How much time do we have, by the way?
90 minutes.
90 minutes. Okay. We can do this. So, my name is Josh Long. It's really nice to be here with you today. Is that the camera right there?
Here.
It feels weird talking. It's like the pandemic. There you go. All right, good stuff. For those of you joining at home, you can't see this, but my laptop is being propped up by Nespresso pods, not Kubernetes pods. Nespresso. All right, so my name is Josh Long. It's really nice to be here with you all today. I work on the Spring team as a Spring developer advocate, a Kotlin Google developer expert, and Java champion. And I've got a YouTube channel, which is, it's not great, but you know, it could do a lot worse, I guess. So join me there, the fun's there. We're gonna do a lot of code. That code is here. And if you wanna find me, if you have questions beyond our brief time together, then of course, here's how you get in contact with me, okay? So all these different channels. And today we're gonna talk about Spring Boot 3.0, or the generation 3.x, right? This is, in my estimation, the single most important release from Spring ever, right? Spring Framework 1.0 came out in 2014, but there were early access, 2004, but there were early access builds in 2003. And so this year, we celebrate 20 years of Spring, something called Spring. And we released Spring Boot early access builds in 2013. And so this year, we also celebrate 10 years of Spring Boot. And so I say that this release, 3.x, to me is the most important, even though I remember in my head, I know there's 20 years of Spring. In that entire time, this is the most important release, as we're going to see today. So let's go ahead and just get started. We're going to do this, as always, by going to my second favorite place on the internet. Obviously, my first favorite place on the internet is production. I love production. You should love production. And we're going to build a new application here. I'm going to call this Service. And the reason I'm going to call it Service is because I'm really good with names. I'm amazing with names, really great. I get that from my father. My father was also really great with names. We had a small white dog, and this small white dog was our pet when I was a child. And that dog, my father named White Dog. And then that dog disappeared after like 10 years. I don't know what happened to him. Maybe he got a job. I don't know. But either way, another small white dog showed up, and my dad named him Too, T-O-O or T-W-O, I don't know. Either way, great with names. I get that from my dad. My mom, she tells me all the time, she says, you're very lucky that I named you. It's true, it's very true. Okay, my friends, so we're gonna build a new application. We're gonna call it Service. We have a choice about what version of Java to use. My friends, there are 4 choices here, 4 radio boxes, but only 2 valid choices. You must use Java 17 or later to be able to use Spring Framework 6 and Spring Boot 3. So these here are just for the jokes, just for the memes, just to find out who makes terrible life decisions. You should never ever select either one of these, ever, in any situation. They are unequivocally wrong. Java 8 is technically inferior to Java 17 in every single way. It's slower, less performant, less syntax rich, less robust, less operations friendly, less container friendly, etc. It's also morally inferior to Java 17. You will not like the look of sadness and shame in your children's eyes when they see you are using Java 8 in production. Don't do this. Be the change you want to see in the world. Do the right thing. Use Java 17 or later. And I say that today, obviously, as we record this at the end of July, almost August, but on the 19th of September, Java 21 comes out. And in the same way that Spring Boot 3 is the single most important release of Spring, I would say Java 21 is probably the most important release of Java ever. And one of the big reasons is for Project Loom. Project Loom is coming in this release. Well, 1/3 of Project Loom will be GA in Java 21. This is a big deal. If you're not using Project Loom, you're throwing away money. You're just burning it. You have money, you take a flame to it and you throw it away, right? That's a waste. Don't be silly. Just use Java 21 when it gets here. So I'm on Java 17, but believe me, as soon as I can choose Java 21, I'll be choosing Java 21, okay? Now, we're going to add some dependencies here. We're going to bring in the actuator for observability. We'll bring in the web support. We'll bring in Spring Data JDBC. We'll bring in the GraalVM native image support. We're going to bring in the DevTools support. We're going to bring in test containers. We're going to bring in Postgres, okay? And I think we're going to bring in the web support. Oh, I guess we're good. Web, Data JDBC, GraalVM, actuator, DevTools, test containers, Postgres. Yeah, looks good to me. Let's do it. So we'll hit generate and open this in our IDE. So here we are, UAO service.zip. So this is a application. Oh, come on, wait for it to download. Go ahead and take your time. I'm not doing anything. Hurry up. Okay, there we go. So I'm going to build a new application. This is a regular stock standard Spring Boot application, obviously. But I want to live the git clone run lifestyle. I want to be able to take this code, clone it, and then start running and working on it very quickly, iteratively. I don't want to have to go through a wiki page with 500 easy steps to development, right? So what I'm going to do is I'm going to use a new feature in Spring Boot 3.1 to enable test containers or Docker Compose at development time. So I have this main code in my production code base, but I've also got this other class, test service application, in my development code, right? So source test Java, test service application. So this is a test main method. It's only in my test code. It doesn't exist in the production build at all, but it has a main method, and I can use this during development. It also has extra configuration. I've got extra beans that only exist during development. And so here, I've got a test container bean, PostgreSQL container, and it in turn is using this Postgres Docker image. And I've got this bean, so Spring Boot's going to automatically start up this container. But then what? Well, if I have a Docker image running with Postgres in the background somewhere, I want to connect to that. I can tell Spring Boot to automatically connect to it by using this @service connection annotation. It'll automatically create a connection pool to the newly stood up Docker image, okay? But the problem is, as fast and wonderful as Postgres is, it still takes time to restart, right? It still takes like 3 seconds to start up a Postgres database. That's a lot, right? And I don't want to have to wait that whole time each time I reset my application. So I will be using DevTools. DevTools is a very simple thing, right? The idea is that I can use DevTools to recreate the Spring application context without having to restart the JVM. The JVM is slow. Spring, fast, okay? So I use test implementation, and then I change the scope there. I'll say restart scope, add this to that, and that'll tell Spring Boot not to recreate this container on each restart. So I'll do run of the test code. Okay, this will take a little while the first time, right? Obviously, it's going to take a little while because it's going to start a Docker image. You can see creating a container for image Postgres latest. Postgres latest is starting, and then eventually you can see it figured out the JDBC connection URL, and then it created a connection pool with the Hikari, and so on. Okay, so now we're up and running. It took 3.46 seconds. That's a long time, but that's okay. That's the last time we have to worry about that. So now what I want to do is I want to build an application that talks to the database, right? So I'll build a domain model here using one of my favorite features, right? This is so nice, so nice. Okay, so I'm going to use that. I'm going to build a repository here, customer repository, extend, whoopsies, list of CRUD repository, managing entities of type customer, primary key, okay? And I'm going to create a class customer HTTP controller, and this will be private final customer repository. Yeah, okay. Add that to the constructor. get mapping customers return this dot repository find all, and then controller and response body. Okay, so pretty stock standard, pretty simple HTTP controller. I want to initialize this database. I have a Postgres database, but I need to initialize it. So I'll create a schema.sql file, and I'll say create table if not exists customer ID serial primary key. Okay, name varchar 255 not null. Okay, and then I'm going to have some sample data I'll put in the file. So data.sql, and I'm just going to insert some data into this newly created table of some people on the Spring team. Right, values. We've got me, hi, nice to meet you. We've got Tommy, hello buddy. We've got Jürgen, obviously. We've got Olga, obviously, and Violetta, and Yushin, and Madura, and Stefan. Let's say, okay? So that's a nice round number. That's 8 records. You can divide it by 2, and then 2 again, still 2. Just makes me feel better, okay? So now we're going to build a property thing. We're going to tell Spring Boot to always initialize the database. So there we go. We've got our HTTP endpoint, our repository, our domain model. We've got some sample data. We've got a schema. We've got that thing. Let's go ahead and restart. But I'm not going to restart the application. I'm just going to recompile on my machine that's mapped to Command-Shift F9, okay? So recompile, and DevTools is running, so it's going to recompile down there. And as soon as the recompile is finished, it reloads the context, and this time it took 0.4 seconds. Okay, I without StreamYard and Zoom running, it's usually 0.3 seconds, so it's much slower right now. I just noticed. Okay, so anyway, let's try that. Customers, did it work? It did work. Okay, so there's our endpoint. There's some sample data, but I want to create an endpoint that gives me records by name. Okay, so I'll say get mapping customers name, collection customers by name, path variable string name, turn this repository find by name. Now, of course, you can see the problem here, right? There is no method called find by name, so I'm going to let the IDE do the work there, and then I'll just do Command-Shift F9. And then take that ChatGPT, and there we go. There's my newly created endpoint. Okay, good. So I've got my simple HTTP controllers. I've got my sample data. Are we done? Can we go to production yet? Are we done? I don't know. Like any idiot can create a REST API. We're not done, right? This is not impressive. Even PHP people can do this. Instead, we need to make this program as production worthy as possible. And the way we do that is to introduce certain, defenses and validations and so on. So one thing I might want to do is I might want to say that the name, let's just say, has to start with a capital letter. Okay, so character is uppercase. Name must start with a capital letter. Okay, very good. Now what happens if this validation is false? Well, it's going to throw this illegal state exception. And I need to capture that somewhere and then handle that in a consistent way. And I can do that in Spring, obviously, using controller advice. So controller advice is just a simple way to centralize error handling. So when that exception gets thrown, I will route the resolution to this. And I'm going to use a new thing in Spring Framework 6 called problem details, right? And problem details, it's just a way to represent the error in a compliant way. So problem details RFC, right? Here's this. There it is. So it's a standard you can use. It's a new thing in Spring Framework 6. So Command-Shift F9, recompile. So now, curl HTTP localhost customers Josh. Okay. Good. And what if I do -v? Okay, good. So that's the correct answer. That's what you get when it's working. Now, what if I do lowercase? Okay, so now I get this problem details compliant representation of the error. Great, small thing, but it's nice. Okay. Now, what else can I do with this? I've got the exception. Maybe I want to look at the request at hand. Maybe I get the header names and I iterate over each value and then just print it out like that. And I can do that as well. Go here. And now you can see on the console, it printed out the host, the user agent, and the accept header. Great, small thing, who cares? What I really care about is this. This is our old friend, the HTTP servlet request. Our old friend has moved homes, however. It now lives in Indonesia, and in particular, in Jakarta. And to understand this, to understand why this is the case, we need to cast our minds back, take our minds back a long time ago, before the COVID pandemic, BC, where in a weird moment in history, Oracle just stopped responding to emails. Now, this is not necessarily a problem, but they specifically stopped responding to emails related to Java EE. And it turns out, if you're the lead of a specification for Java EE, you can't just stop responding to emails. Otherwise, nothing can get approved. Nothing can get done. And if you don't get anything done, then the whole process just comes to a crashing halt. So this is bad. It means that one company was able to completely stop the entire community from moving, right? Very, very bad situation. Not open at all. It's the opposite of open. It's, well, closed sounds not as bad as this. It's worse. It's like closed with poison or something, you know? So what happened? After about 6 months, the community forced Oracle back to the table. They open sourced everything. They agreed to open source it, right? And this is a very big deal because it meant that finally things were going to be open, right? Truly open. Open source is good. So what happened? Well, they donated it to the Eclipse Foundation, right? Where it became Jakarta EE, right? So we had Java EE, and that became Jakarta EE, right? Yeah. So there's that. And then we had a weird few years. We had Java EE7, right, under the JCP, the old non-open thing. Then they have the Jakarta EE8, and Oracle, they agreed to open source the code, but they have a little requirement in there that makes things very difficult, which is if you change anything, if you add a method, delete a method, add a type, delete a type, etc., it has to be in a new namespace. Well, this is not great, right? That means that effectively you could open source Java EE and you could keep releasing the same code over and over, but otherwise you can't do anything to it, right? So they said, okay, fine. It can be released to the Jakarta EE Eclipse Foundation, and so the Eclipse Foundation released Jakarta EE8, which is exactly the same as Java EE7, but it has the new license, new TCK because Oracle did not donate that, and new documentation because Oracle did not donate that, okay? Then the Eclipse Foundation released Jakarta EE9, which is exactly the same as 8, which is exactly the same as 7, except it has the new package, okay? So what does this mean for you? Well, it means that every bit of code ever written against these standards for the last 20 plus years now doesn't compile. It's broken. Thank you, Oracle. But it is also a good thing. If you move to these new types, then, well, you know, they're going to move faster now. They can evolve more independently. They're not tied to one company and its bad ideas, right? This is a good thing. It's a very good thing for everybody. So Spring Boot 3 uses Jakarta EE9 and later, and it uses Java 17 and later. These are the baselines, okay? So there's that, okay? What else? What else can I do to make this application more production worthy? Well, another thing I might do, of course, is introduce observability. And obviously, my buddy Tommy, his eyes just perked up. What I want to do is I'm going to take this application and make it so that I can kind of understand what it's doing. Observability is this idea that I can understand what the application is doing by observing its outputs. And it used to be, in the old world, in the Spring Boot 2 timeline, we had micrometer.io, right? And this does metrics. And then we had Spring Framework, and then Spring Boot, and Spring Cloud, and then Spring Cloud Sleuth. And this did distributed tracing. And so the problem was, as you can imagine, if you're on the Spring Boot team and you want to add tracing to an API, you can't do it because you have to pull in Spring Cloud Sleuth, which in turn uses Spring Boot, which would then use Spring Cloud Sleuth, which in turn uses Spring Boot. You get a circle, right? You get a circular dependency. So this is a problem. So in 3.0, the new world, we got rid of Spring Cloud Sleuth and we pushed tracing down into here. So now we have this new unified library for observability, right? Micrometer is a vendor-neutral application observability facade. It's think SLF4J, but for observability. And it has integrations with all sorts of different time series databases and distributed tracing systems, right? So this is very, very useful. You can plug in any implementation you like, Prometheus, Graphite, Wavefront, Datadog, OpenTelemetry, OpenZipkin, etc. Right? Good stuff. Okay. Now, to make things even better, there's a new API, a new unified API that you can use called an observation. Right? So create not started by name, and in order for this to work, we're going to inject the observation registry. Okay. Thank you. We'll say this dot registry dot observe, and we'll take that, get rid of that, there we are. Okay, so this creates a metric. This creates a context in which we can do distributed tracing. So if I want to see all this in action, though, I need to either set up these time series databases and distributed tracing systems, or at the very least, expose the actuator endpoints, which I'll do here for our demo, right? Okay, there we go. Very good. So reload, localhost actuator. You've got these different managed HTTP endpoints that give you information about the state of the application, your caches, your health, etc. Your health shows you your health components. You've got your conditions, your config props, your environment variables and system properties, your loggers, your heap dump, your thread dump, metrics, schedule tasks, and mappings. All the stuff is there. But what we care about here is the metrics, right? You can see I've got metrics or statistics about the application, like how long it took for the application to start up, how much disk space is free, how many connections I've got, how many servlet sessions I've got, how many processes are running, etc. Okay. Well, I don't see any mention of the by name metric that we just created. Let's try and fix that, shall we? So while true, do curl HTTP localhost 8080 customers Josh. Done. We'll just let that run for a second. Okay, go back. And there, you can see it says by name. And if I go there, you can see I made 175 requests, and here's the total time and all that. Okay, so now I've got this application that is, it's been instrumented for observability. I can easily plug in any of those different time series databases. It's got distributed tracing support if I want it to, right? It's got validation. We're using git clone run. We're using test containers, dev tools, things are moving. We're moving quick, and things are now, I think, at a place where we can think about moving this to production. And here, my friends, this is a question of packaging. How are we going to package this application? The first kind of packaging that we care about, of course, is turning it into a container, right? And obviously, the answer for how do I containerize my application these days is build packs. Build packs are a cloud native computing foundation specification. They help you package any kind of application artifact, .jar, .war, Ruby on Rails, Python, Node.js, .NET EXEs, I can't say it, it's not a language, but that one too, it can do all those things easily and containerize it for you via the pack CLI. If you're using Spring Boot, then of course you can just do maven w spring boot :build -image or gradle w build boot image, right? Either way, that'll also run build packs for you. Remember, friends don't let friends write Docker files. Don't waste your time. The second you do it, the very second you write a Docker file, a few seconds later, there's going to be a security vulnerability in that Docker file. It's a fact. It's physics. Just instead use build packs. It's just much better. It represents the collected wisdom of tens of millions of deploys across Heroku and Cloud Foundry. You don't have that experience. Nobody in your organization has that experience. Just use build packs. Much better. So that's the first question. The second question then is, how do I make my application as fast and efficient as possible, right? And here, my friends, it's worth just stating up front that I think Java is already very efficient and very fast. And I think this is this point is made well clear by this blog, that asks the question, which programming languages use the least electricity? And this is from 2018 BC. And there's a great table in here that looks at that, right? And it says normalized global results for energy, time, and memory in different languages. And so you can see that C is the #1 most efficient language for machines. That's just important to stress that. Not for people, for machines, okay? And then Rust, zero cost abstractions, doing quite well. Good job, well done. We've got C++, disgusting, moving on. We've got Ada, who cares? And then Java, okay? Java's in the top 5 most efficient languages. amazing, right? Especially considering how not dynamic these other languages are compared to Java, which is, after all, an interpreted dynamic runtime, right? And yet it's still in the top 5 most energy efficient languages. And let's just, for easy math, for simple math, let's just say Java is 2.0, okay? Make it simpler. We'll just round up, all right? Take a little bit away, but that's okay. Easy, simple math. Let's keep that in mind. So Pascal, okay, Chapel, Lisp, Swift. If you've used an iPhone or an iPad or a Mac, you're using Swift somewhere, right? That's the language of that device. You've got Go, Away. You've got JavaScript and TypeScript. And by the way, look at this. How does this 4 times, why is this 4 times worse than that? That's absurd. Why? I thought this compiled into that. That's, I mean, it's completely, it's surprising, but not unexpected given JavaScript's shenanigans, okay? Like, somehow it feels like this is exactly what should happen, but also it's surprising that it does actually happen. Then we've got these 2 languages. The less said about them both, the better. Moving on. And then we have Ruby and JRuby. Notice that JRuby is like 33% more efficient than Ruby. Remember, JRuby is the Ruby language interpreter written on the JVM, which is interpreted. Ruby is the Ruby language interpreter written in C, which is not interpreted. And yet the JRuby, the one on Java, the interpreted one, is 33% more efficient than the C code version, right? That's incredibly impressive. The JVM is an amazing piece of technology. It's a miracle. I mean, it really just really, really good, okay? So, yeah, well done, right? This is amazing. And then there's Python. Oh, this really makes me sad too, because I love Python. I mean, I have been using Python since Bill Clinton was president in the United States, right? Like the 1990s. I love Python. And so this number really just makes me not happy. Like, look at this. Let's just round up, okay? Round up again, 76, okay? So what was that number from before class? We take it, we can just ask Python. 76 divided by 2, that's 38, okay? Now, 38, what that means is if I write a program in Java, and then that program uses electricity, and then the production of that electricity results in carbon being emitted and captured in the atmosphere. And then that carbon kills 1 tree. If I do the same program in Python, I kill 38 trees. We should not be okay with that. That's a big problem, right? It's a forest. It's a forest. It's almost as bad as Bitcoin. Just a terrible result, okay? 38. So I love Python, but this needs to improve, and it needs to improve yesterday, especially now that Python is dominating AI, okay? I'm just saying, not great. And then, of course, Perl, but who cares? Moving on. So Java, top 5, already really good as a language, okay? Really quite impressive. And it's only getting better. And I think we can say that it's so good for 2 reasons, right? First is the Java programming language garbage collector. The garbage collector is an amazing piece of technology. No doubt about it. It allows us to write code and then not worry about how our mess gets cleaned up. I love that, right? But I think it's a little ridiculous that it is that people would claim it's the first Java garbage collector. I think that honor surely belongs to her. Her name is Jesslyn. She is from the island of Java, Indonesia, and she is a Java garbage collector. She is the original Java garbage collector. And what I love about this world, I don't love much on the internet. The internet is a terrible, terrible place. But look at this tweet or post or whatever it's called now. 19.7 thousand likes. The internet is just garbage, but this is great. The internet, good job, everybody. We did good on this one. Good job. So, okay, that's the first thing. The other reason that the Java programming language is so amazing is because of the just-in-time compiler, right? The just-in-time compiler, the JIT, just-in-time. The just-in-time compiler is, you've seen it before. The idea is that it looks at your code, it finds the code that's executing many times, and if it can, it turns it into operating system and architecture-specific native code. And it does this for things where it can be sure that the type system is complete, that things are not going to change during the run of the program. So it works well for things like, it doesn't work well for things like reflection, serialization, JNI, resource loading, proxies, JDK proxies, right? All these kinds of things where types might escape the type system, that can be a problem for the just-in-time compiler. But still, the results can be pretty amazing, right? I mean, the just-in-time compiler is, large organizations have used it, and they turn on a small subset of traffic, use the just-in-time compiler to warm up to turn the code into native code, and then they release production traffic onto that JITted code base. It's an amazing result. So the question then is, if the just-in-time compiler is so good, then why don't we just proactively, ahead of time, turn everything into native code? And obviously, this is a problem well answered by GraalVM. GraalVM is an open JDK distribution. It is a open JDK distribution with a few extra utilities, including a native image AOT compiler. And so GraalVM is amazing, but we still have these problems. We still have, even with AOT, even with GraalVM, right, ahead of time, right? Even with AOT, you have these issues where if you have things that might escape the type system, then you get in trouble. It won't work, right? Things will break. Now you can fix this. There is a way to fix this. You have to provide JSON files, okay? Or you can do command line switches, but most of the time you're going to do JSON files. And I have two issues with this. First of all, I hate saying the word JSON. It just sounds really stupid in my American English accent. I don't like it. It doesn't feel good saying it. I have a hard time not laughing at other people when they say the word JSON seriously to me. Like, come at me with JSON. I will laugh in your face. I will. You sound dumb. You don't sound good at all. So JSON just sounds dumb. I speak French, and in French you can say JSON, which sounds cool. Sounds much cooler than JSON. Okay. I was in Taiwan recently, and there a lot of people speak Hokkien, right? And there you can say Jingson, which means happiness, right? So that sounds cooler too. So Jison or Jingson, but none of this. No more. I'm done. I'm team Jison. You can be whatever you want. Okay. Let's just move away from JSON. It just sounds stupid. So that's part one. Part two is there's a lot of JSON that's required in order for this to work. There's a lot. I mean, you have to think about all the places in your code base where this kind of stuff happens, right? Even your logging libraries, your test frameworks, your data access, your web framework, everything, your servlet container, everything does this, right? Some of this, if not all of it, right? Everything. And so you have to provide a lot of JSON for this to work. And it's just a lot of work. I don't want to do that. So there's a new feature in Spring Framework 6 and in Spring Boot 3 to generate that for you at compile time. That's an AOT engine. Okay, so we're going to go ahead and kick off a native compile, and we'll let that do its work. And it's going to spin up, and it's going to do its thing in the background. And here we just kind of have to wait. That's the real problem with the GraalVM. That's the one cost, is that these compilations just take forever. I mean, they just take so long. Long enough, in fact, that it just kind of takes the wind out of my sails, you know? I just feel very bored. I hit a wall because I like to move fast. I like to code. I like to be in the zone. But with this, you got nothing. There's nothing you can do, you know? You just get bored very easily. And it just takes the fun out of the experience, right? And now, frankly, sadly, I understand this cartoon. I didn't want to understand it, but I do now. Which asks the question, what is the number one programmer excuse for not doing the work? Like code is compiling. The boss says, hey, get back to work. Compiling. Oh, okay, keep going, right? Makes sense. I didn't like this joke before because I didn't understand it, but now I do, and it's hilarious, but I don't want to understand it. This is not a good situation. But that's okay. So anyway, I don't know. It just takes a long time. It really just takes forever. And eventually I get very kind of bored, you know? I have a hard time just sitting there doing nothing. It's not long enough that I can go to the bathroom or like make a cup of coffee. I can't do like biological I/O, right? But it's also long enough that I can't keep doing anything else. It's just a noticeable pause in my day, and I hate it. And eventually I start to hear elevator music. Do you know what elevator music is? You ever get into an elevator and they're playing music on this loop just to keep you hearing something? Well, now I hear it in my head when I do these stupid compilations, right? And I thought, wouldn't it be great if everybody could hear elevator music as well? So So I went to Oracle and I said, hey, Oracle, buddy, pal, please play elevator music during the native image compilation process. I said, I already hear elevator music in my head while I do these sometimes long-running compilations. I'd just like everybody else to hear it too. Thank you in advance, and I appreciate your amazing work. And I do, by the way. I really do. I appreciate what they're doing over there at Oracle. And so I got some great responses, including this one from Andrew Din, one of our friends over at the Red Hat team. He's a distinguished engineer on the Red Hat Java team, OpenJDK project reviewer, Byteman project lead, and a Growl developer. So clearly, this thread was a great use of his time. And he says, please, can you make it this elevator music? And yeah, I would like this. So this is from the James Bond video game. There's a James Bond video game in the 1990s based on the James Bond movie, and they made a Nintendo 64 game called GoldenEye based on the movie. Right. So, and then this is from the soundtrack for the video game for the movie from the 1990s. Okay. I'm not going to play it, obviously, but yeah, it sounds great, right? This is actually like, I think that would be a great idea. That would be good music, good stuff, good suggestion. I approve. Okay, what else? I would add, says Ivan, that using beeps in general, not only for native image, really helped me to reduce development time. Yeah, that's a great idea. That's a really good idea. My rice cooker will make a ding sound when it's done. Why can't my compiler? This just seems very obvious. And then I got another great response from this gentleman. This is Fabio Niebhaus. He's a researcher on the Graalvm team at Oracle Labs. He's a PhD. He's a doctor. He's one of my favorite doctors, along with Doctors Hu, Strange, Seuss, Subramaniam, and Sire. And he is previously at Google Colab and Matan Guitars. And he said, thank you for the feature request, Josh. The problem with playing music during the compilation process is that it's just fixing the symptoms. And we've been and are still working on the cause, making Graalvm native images more efficient in terms of time, memory, and CPU consumption. Anyway, he continues, I have prototyped a -- Josh Long mode. So here's what that would look like, okay? So this is what this would be, okay? So you do -- Josh Long mode, right? And then you can see, let me open this image here. There we go. So you would run the compilation with native image, and then you'd hear music. This is a picture, okay? You're not going to hear the music from a picture, but just imagine there's music. And then it would print out music brought to you by Josh Long. And then the compilation's still going, and you want something to look at, right? So obviously you'd get this, right? That'd be great. That's the feature in the future I want to live in. I'm sure it'll be merged any day now. I don't know when, but soon. I forgot what we were doing. Oh, right, the compilation. Let's see here. So yeah, there you go. It finished in 1 minute and 15 seconds. Let's go ahead and run it. Boom. Okay, problem. Already in use. The port, the service is already in use. The address is already in use. So we'll go here. Stop that. Go back to this. Run again. Okay, next problem. Can't find the data source. There's no URL. Well, of course, right? I'm using test containers. I'm using the service connection attribute. So obviously, I didn't have a application-dev.properties or something like that with my local development database. And I don't have production credentials stuffed in my application properties because I'm not an animal. So I need to specify this connection information. So I have a little program over here. Let's get out of here. Go to desktop. cd talk. So I've got this Docker Compose file. I'll do Docker Compose up. That's going to run a Postgres database with username and password BP. Okay, there we go. And then I've got a little script. And this script will export the environment variables, Spring data source URL, Spring data source password, Spring data source username. And it just points this to the database I just created, and then it runs the binary that we just programmed. Okay, so boom. Okay, there we go. So the program started in 0.148 seconds, which is nice. It's fast, faster than a light bulb. But still, if you're really after speed, you're probably doing something like Knative or Lambda or something like that. In which case, you don't need a full Tomcat web server, right? That's not going to make any sense. You should probably be using something like Spring Cloud Function and then use that with Graalvm. AOT support. Okay, so the application's up and running. It's fast. And fast is nice, but actually I don't care about fast as much for this kind of application. What I care about, however, is this. This is the process identifier, okay? And I'm going to measure the RSS. So RSS, resident set size, is a measurement of the portion of memory occupied by a process that is held in RAM, okay? So basically, it's the measurement of how much RAM an application is taking, okay? Very simple thing. And it's measured, importantly, in kilobytes. So if you get a number for RSS, you divide by 1,000 to see how many megabytes, okay? Okay, so there's the number. So that's 109,000, right? Or put another way, it's 109 megabytes, right? 109 megabytes, basically. So that application is taking about 109 megabytes. Now, what is it? That's really good, okay? That's really, really freaking good. And just to drive the point home, I like to, whenever I'm bored, just find out how much of my computer that I paid thousands and thousands of dollars for, Chrome is using. So here it's taking 62. You can't really see it, can you? I can't zoom in either because we're using StreamYard and Zoom and 5 different things. Okay, so 62, 63, 34, 165, 39, 261, 45, 57, 39, 17, 64, 39, 22, 95, 32, 84, 111, 106, 45.7, 79, 413, 13, 17, 32, 200. I mean, this is all just Chrome. Wait, the thing that handles when Chrome throws an exception is taking like 9 megabytes. Just the crash handler is taking 9 megabytes of my precious RAM. It even fails with a lot of RAM. Like so terrible. So this is gigabytes just to run a stupid browser. And yet this application now is just 100 megabytes. That's awesome. That's what you want, right? That translates into real value in a production system. And I don't know how much RAM your application is taking, but I remember 2003, so 20 years ago, I went into a data center. Maybe you all, I don't know. A lot of times I'm not sure. Data centers are big buildings full of computers and there's air conditioning, right? It's very cold. So you go in there and they're trying to air condition the machines. And so you go in there with a big fluffy jacket. And this is 20 years ago. This is before we had like 24/7 high availability, all day, all night kind of services. So I went in at midnight and we're going to upgrade our systems and upgrade the operating systems and all that stuff. And so we went in, plugged in a patch cable, and I was just looking around. It was just like, oh, okay, how much RAM is this thing taking? Okay, great. Back then, this is 20 years ago, we realized already that back then, when dinosaurs were still roaming the planet, we realized already how terrible an idea an application server is, right? And so what happened was you can't really do isolation in a Java process, right? You can't have more than 2 applications in the same Java process space. They tend to clobber each other. You get noisy neighbor issues. And so just because of ease of deployment and ease of maintenance, we always had one application server and one application, never 2 applications per application server, 20 years ago. And I remember looking at these applications and thinking, oh, I can only allocate 2 gigabytes of RAM, 2 gigs, 20 years ago. I wanted more. We all did. But back then, this is when we had 32-bit CPUs and 32-bit compilers. So we couldn't reasonably allocate more than 2 gigs because the JVM would get these halting garbage collection pauses, right? It just wasn't like it. I mean, you could do it. It's just, it wouldn't work very well. It'd be very slow, right? You get these stop the world pauses. Now we have 64-bit and you can allocate, as much as you want, right? But you don't need to. You can, here we are. That's 5% of what I was taking 20 years ago. I can run this application. It's an amazing place, amazing time. Okay, so we've got our service. It's up and running, right? We can prove it. Localhost customers. Et voila, there's that. Good stuff. Now what? Now I want to build a client. So I'm going to go back to start.spring.io. I'm going to name this one client because, again, I'm really great with names. Use GraphQL. We use Spring Cloud Gateway, DevTools, GraalVM, and the reactive web support. Okay, so Spring for GraphQL, Spring Cloud Gateway, Spring Boot DevTools, GraalVM, and reactive web. And this is going to be like an edge service or a backend for a front end or API gateway, whatever. There's a lot of different names for what we're trying to build here, right? But basically, we want something to sit in between our downstream services and the clients that are connecting to them via, our iPhone or Android or your Toyota car or whatever. All these things have SDKs. They all talk to backend services. And so we want to handle these client-specific concerns without having to change all the downstream microservices. So one way you might do that is just to build an API gateway, okay? So let's suppose that this is running on port 9999. And let's say I want to create an API gateway using Spring Cloud Gateway, okay? Route locator builder. RLB, return rlb.routes.build. There we go. Oh, there we go. .route, and then we create a route specification. And here we're matching the request on the predicate. So you can do and cookie is, whatever, and you can do all that matching, right? But I just want to match the path, and I want to forward the request to localhost 8080. Okay. Excuse me. So I want to change that. Now the thing is, I'm proxying the request from /proxy, and I want to send it to customers. Well, obviously the path is already proxy, so I need to swap out the path, and I can do that by using filters. So here I'm going to say set path to customers. Okay, and if I change the path to customers, then I can act on the request. I can do all sorts of other things here too. I can do retries. Maybe I want to do a CORS header like this, like that. Maybe I want to do a JSON to gRPC, right, like this. Maybe I want to do rate limiting, like that. Maybe I want to do circuit breakers like this. Maybe I want to do whatever, all sorts of interesting things. Maybe I want to do OAuth, right, token relay for connecting to an OAuth IDP, and then acting as a client here so that you can reject requests that don't have a valid token. You can do all sorts of things here at the filter level. And if you don't see something that you want, then just write a new filter, right? You can easily do that as well. It's very, very straightforward API. Okay, so let's just go ahead and try this. We'll run this. Okay, localhost 9999 proxy. There's the data, right? If I go here, curl -v JQ, you can see I get all the data from that call, but I'm also getting access control allow origin. So I'm actually adding the header without changing the downstream microservice. Simple enough. Okay, what else can I do? Well, I'm at the edge service now, and maybe instead of acting on the request like I am with a gateway, maybe I want to act on the data itself. And so here I can just build a client, right? And this is pretty straightforward. We, class customer HTTP client, and maybe I inject the reactive non-blocking client like that, and maybe I create a method here like this, and okay, but you can already see a few problems, right? First of all, I don't have this type on the class path. So I'm going to do something terrible, something that you should never, ever do, ever. Not even when you're all by yourself at home and no one is looking. I'm going to copy and paste code. So I'll go back here, take this, paste that into the buffer, like so. And then there we go, okay? So now, let's see. I want to get rid of that, turn this into an interface, and I'll create an endpoint here, get exchange, customers. And, I can add another method here to get the by name version. And this is a feature that's new in Spring Framework 6. You've seen this probably before in some form with Spring Cloud OpenFane or Spring Cloud Square Retrofit or whatever, but now this support has been pushed down into Spring Framework itself. We have implementations for both HTTP and for RSocket, and in theory we can build more. And now we can build a client, right? So now we just tell Spring to build it for us, and the way to build it is you inject the reactive non-blocking HTTP client, and you build a web client adapter for that client, builder.base URL, HTTP localhost 8080.build.create client. Okay, and there you go. So now what can I do with that client, right? I've used this machinery to automatically create an implementation of that interface. Now what do I do with it? Well, maybe I'll inject it and use it when the application restarts to call the service, right? So HTTP customers subscribe print line like that, okay? If I do that, of course, you can see there's the data, right? Great, it worked, fine. Now, what would I really want to do with this client, right? Well, what I want to do is I want to build a view of the data that supports the use cases of my actual client, like my iPhone, my Android. There's a bit of a tension here, right? If I build services on the back end, my inclination, my instinct tells me to create small, singly focused, separate services. But your iPhone developers and your HTML5 browser developers and your Android developers, they don't want 10 different services that they have to talk to. They want to go to one service and get as much data as possible quickly. Too much conversation is bad for mobile devices, right? You don't want to have an Android device with 2% power having to make 10 different network calls before I can show you a screen, right? That's bad for everybody. So there's a conflict there. We want our services to be separate, but the clients want everything all at once, and they want to avoid round tripping, and they don't want to get extra data that they don't need that costs bandwidth. Well, I think GraphQL is a really great way to sort of fix both of these problems. So we're going to create a GraphQL schema here using Spring for GraphQL. So schema.graphqls. Okay, GraphQLs. And you can describe your types in this schema like this. And there's my custom domain type, okay? In GraphQL, you have 3 verbs, 3 actions, right? You have mutations for add, delete, update. You have queries for request response. And you have subscriptions for streaming, yeah? So these are the 3 verbs. If you understand that, then you're already done. That's it. It doesn't get, there's no like arguments. There's no discussions around, oh, do I do a post or put, or do I need options? What if I do a patch? And like, do I send a 201 or 202 status header back? Should I have the location header? What if the creation takes too long? Should I send back the location for the status of the URL of the thing that's being created and then send that in the location header? All that nonsense, all that ridiculous back and forth that people have to do with REST just goes away with GraphQL. They're still arguing about that while you're home with your family having dinner, right? It's much, much nicer, much more pragmatic. So here, we're going to build a query. A query is a special, well-known type that exports the fields that are available for request-response kind of interactions, okay? So I'm creating a field called customers. I'm creating another field called customers by name that returns an array of customers, okay? So this is a collection, a bracket. You know, if I just did this, that'd be a single one, but I'm going to do a collection. Okay, so this is a special type called query. There's also a special type called mutation, obviously, and another one called subscription. Okay, subscription. So those are all fine. Now, I want to implement the controller for that schema. So we're going to go back to here, get rid of that. Customer GraphQL controller, private final customer HTTP client. There we go. And, you know, we are going to implement methods that get called when somebody's trying to resolve those fields on the type called query. So the field is called customers. And this is just a regular controller, by the way, just like you've seen before. So controller. Okay. And so I'm going to say return this.http customers. Okay. Now, obviously, the field, I can derive that from the name of the method, so I don't have to specify that. And actually, remember, I said queries and mutations and subscriptions are special. They're common cases. So there's actually a specialized annotation called query mapping, which is like a request mapping, but for GraphQL, and the default there is query. Okay, so this and that are semantically identical. Well, what about the other one? Well, let's do that as well. So we'll go here, and customers by name, argument, string name, yeah, by name passing in this. Okay, now I want to try this out. So I need to have a way to test my endpoints. So I use this GraphQL, interactive query. Go here, localhost 99 GraphQL. There we are, okay? So now, friends, first of all, I love this because, okay, there you go. First of all, I get nice control space ability. I get schema after all. That's nice. Look at that. I've got schema. I can see the types. I can see how they're related to each other, etc. hit enter, I get back all the customers. What if I want all the customers and I want to get that customer by name, right? So I can do this too. I can say Josh ID. Okay. So now I'm making 2 different calls to 2 different endpoints, but I'm getting all the data back at once. I don't have to make 2 network calls to get the data, right? So you can imagine like a page where you have different islands of functionality. You need like catalog, the products over here and the orders are there and your messages and whatever, all these different islands. You just have one GraphQL call when the page loads with JavaScript or whatever, get all the data back at once, and then you can populate everything in one file, in one go, okay? So this is nice, and it's already an improvement over REST. And by the way, notice that if I don't want, let's say I don't want the name data, then don't get it. If I don't need it, I don't ask for it and I don't get it back. What if I don't want the IDs? Then I don't get it back. I'm not gonna pay for the extra bytes of data that I'm not using. This is how you create efficient services. Okay, well, let's say I have another service, another microservice called the profile service, okay? And let's say that profile service has a new type called profile. So type profile, and you can find a profile for each customer. So we can add profile to this customer, okay? Pretty straightforward. Well, I need to change the customer and have it point to this profile. So now I need to go ahead and graph that in, basically. So I'm going to go here. I'll create another method. This time the type is called customer, not query, and the field is called profile, right? We saw the syntax earlier. I'm going to create that type now. Record profile, integer ID, okay? So I say profile. Now, imagine how this is going to work, right? I'm going to return a new profile for the customer. What customer, right? Where do I get that? Well, I can inject the root type in there. I can say customer.id, okay? So, system out, returning profile for customer, okay? Command Shift F9, go here, refresh, get that. I'm going to ask for the profile data, okay? Get the ID, and voila, okay? So there's Josh, profile 35, Tommy, profile 36, Jürgen, profile 37, etc., right? So it's getting back all the data for each customer, right? And same for there, I'm getting the exact same thing. Now what's happening when I do that though, right? If you go here, let's clear that, and then go here again. Now you can see it's calling this method. Each time it's trying to resolve the profile for the customer. Imagine this was actually a network call, right? Like imagine HTTP profile, let's see, profile -service / profiles by customer ID, something like that, okay? What's it doing behind the scenes and the other service? Maybe it's like select all from profile where customer ID equals this, okay? So imagine it's actually doing that. Well, there's gonna be some latency, right? So what happens if we introduce latency? Throws thread, throwable, Command Shift F9, okay? Go back, oh, there we go. Ooh, not good. So the engine is resolving each profile for each customer one at a time, one after another. So it goes to get the first one, then waits a second because there's latency. Once that returns, it does the next one, and so here I've asked for the profile for this one customer and the profile for all these other customers. So that's 9 requests because we have 8 total customers plus the one for the by name. So that's 9 total calls. So I'm getting all the customers and then I'm getting the profiles. I'm making 9 network calls to the profile service. That's not good. N+1, right? We have the N+1 problem. Okay, well, one thing I could do to make it a little bit better is I use non-blocking reactive types, okay? So imagine I'm making the same network call, right? But I'm using non-blocking types, and that wouldn't be hard. Again, I could use that interface that I just built, right? And let's say I get rid of that and I say delay element of seconds, okay, 1 second, okay? So now it's still blocking, it's still waiting a whole second, but it's reactive, so it just waits 1 second, not 9. It's doing it concurrently. It invokes the handler, immediately returns, invokes the next one, immediately returns, and then waits a second for it to resolve, but it's being resolved at the same time for all 9 of them. So that's much faster. The time to first byte is now, much, much faster. Okay, well, still, this is kind of ugly though. Look, I'm still making 9 different network calls, right? If you go here, there you go. It had to call that method 9 times. I made 9 different network requests. But okay, it works. I'm getting the data as I want. But what if I had a better endpoint? This seems a little painful. What if I had a different endpoint? What if I had an endpoint where I could do like select all from profile or customer ID in, right? I could have like a collection of IDs, etc. Right? Now I could say, give me, given a bunch of customer IDs, 1, 2, 3, 4, whatever. If I had an endpoint like this, then I could get all the profile data back at once. So let's rewrite this to use batch mapping, okay? Batch mapping uses the GraphQL Java data loader mechanism. So profile, and the contract is a little different here. I create a map, new hash map of customer of profile, okay? For var c customer, map.put c and new profile, c.id, return map. So the contract is, I've rewritten the network endpoint so I can do a select all from where the ID is in a range of IDs. So I've got all these customers at once. Okay, so system out returning customers, returning profiles for all customers, right? Customers, blah. Okay. So now go back here, refresh. Okay, and scroll all the way down. Clear that again. There. So now I got the GraphQL engine knows that I need 9 different profiles from 9 different customers, even though it's 2 different requests for customers by name and for customers. And so it gave me a collection with all the customers, and it said, here, go find all the profiles for all these customers. And so now I can easily return a map that gives it an explicit, mapping from customer to profile ID, right? So now I'm avoiding all this round tripping. Now I've just got 2 network requests. Easy. Okay, well, we've got our GraphQL engine. We've got our nice clean API. We're using this new declarative interface syntax from Spring Framework 6. We're using GraphQL. Obviously, I think we've got an application it's looking pretty good. Let's little W native compile that. And then let's just talk a little bit about the future. So Spring Framework 6 came out last year. Spring Boot 3 came out last year. We're at Spring Boot 3.1. Spring Boot 3.2 comes out in November. It comes out in September? Java 21. Java 21 comes out in like 45 days, September 19th, right? More than 45 days, whatever, 50. Very, very important release. In my opinion, the most important release of Java since 1.0, right? And it's because of this thing called Project Loom. Now, to understand Project Loom, you kind of have to look at basic Java code, right? Var input stream equals to do whatever. And then you just look at this code. You've written this code before. We've all written this code before. It's like Java 101, at university, right? I could write it blindfold. Do something with next byte. Okay? I'm copying data from this input stream, and I'm reading the data 1 byte at a time. Okay? Well, what happens if this is like a file and you're reading data from a new file input stream, then you probably won't notice this. But this is technically a blocking call. When you call .read, it waits until it has a byte before it returns. If there is no byte, it doesn't return. So with a file, you're not going to notice it because most of the time, there's no latency between file disk and your RAM. It just dumps it right into RAM, right? But if you're doing a network program, then you're going to see that, right? If the client connects and then doesn't send if the request gets truncated or whatever, you don't get any more bytes. And this is a problem because you have to wait for that next byte. And in the meantime, the thread that you're sitting on is unavailable to everything else in the system. This is bad. Now, there are ways to get around this. You can use NIO, and that sucks. So they built NIO2, which sucks. So then our friend over in Korea, Seoul, Trustin Lee, fellow Java champion, he built Netty because he's awesome. And Netty is a very very nice way to do asynchronous non-blocking I/O, but it's still a little low level, right? People don't like to think about the world in terms of non-blocking I/O or I/O at all. They think about it in higher level stuff. So then you get things like, reactive programming, right? Obviously. And I love reactive programming. I think it's a great way to build systems. It gives you 3 big benefits, right? Ease of composition, error handling, scalability, right? Better thread reuse. So Project Loom gives you this last one for free. Project Loom is, and this is maybe the most important thing for a lot of people, right? So Project Loom gives you the ability to write this code, and it automatically detects that this is taking a long time, and it moves it off of the current thread until there's another byte. And the result is it's now decoupling the operating system thread from the Java lang thread. Right now, today in Java 20 and earlier, one Java lang thread equals one operating system thread. And if you are sitting there waiting for another byte and you're just wasting time on that thread, nobody else in the system can use it. Threads are expensive. It takes about 2 megabytes of RAM for every thread. So you can't really create a lot of threads. In fact, we've got that famous C10K problem. This is not even about threads, right? I'm not sure if this is the right one. Please, somebody tell me. C10K problem? I don't know where I am. Okay, let me just go back to C10K, please. There you go. This is not even about threads. It's about optimizing network socket I/O, right? Can I have 10,000 simultaneous file descriptors, basically network sockets open and doing multiplex read and writes? Most people can't even get to that problem because they're still stuck with, how do I have 10,000 threads? You can't do that in Java today. It's not practical. So you have to do something like non-blocking I/O with selectors and epoll and things like that to make this work. Now you can. By doing what they're doing with Project Loom, you can just change the code. You're using the new executor service, executors.virtual task executor, and everything else is the same. Nothing changes. Now you get the same kind of scalability as you get from reactive programming for free. This is huge. That's coming in 45 days. So what are you doing in 45 days? You're upgrading to Java 21. Repeat after me. I'm going to upgrade my code to Java 21. Do it now. Get it ready. Do not waste. Like, if you come to me after Java 21 is out and you're not using Java 21, I'm just going to assume you hate having money and you just want to get rid of it. You just don't like it. You're just tired of it. And if that's the case, I want you to give me your money. Okay? If you don't like it so much, just give it to me. There's no reason not. It's just free scalability. You just upgrade. It's sorcery. It's magic. It's like Go. The Go runtime, the Go lang, Go routines is exactly the same thing as what's happening in Java. It's the only thing out there that even comes close in terms of elegance to Project Loom. Huge deal. And then GraalVM, of course, they committed to releasing GraalVM basically in lockstep at the same time as Java. So not too long after Java 21 comes out, GraalVM for Java 21 will come out. So now you can write a native program that takes 100 megabytes of RAM and handles tens of thousands of requests or millions of requests, like with your existing code. All you got to do is upgrade. Upgrade. Just do it. You can do this. Be the change you want to see in the world. So Spring Boot Spring Boot 3.2 comes out in November. It will have an integration. So you can just use there's a property you can specify so that you can opt in to use virtual thread pools instead of using the regular existing ones if you're on Java 21. So you take your existing code, upgrade to Java 21, upgrade to Spring Boot 3.2, property. Now your thread pool for your web front end and for your Spring Batch and Spring Integration and Spring MVC, all these different thread pools are now using virtual thread pools. Yeah, sounds good to me, right? This is a great, great time to be a Java developer. It just is. Okay, let's see. Build, native compile, client. Ta-da! It worked. Of course it worked. All right, my friends. Well, I want to thank you for your time. Hope you got something out of it. I'm happy to answer any questions, comments, feedback, whatever. Yeah.
Can I ask one?
Yeah, please.
Does the GraalVM support the Apple Silicon now, Cherry?
Does it support what?
Apple Silicon.
Yeah, I'm using Apple Silicon.
Oh, really?
Yeah. That's why. If you're on Intel, that GraalVM compilation is going to take a lot longer. It took a minute for me, and it was unbearable. For Intel, it's no, thank you. And amazingly, this is one of the reasons I love our community. The first group that had a working working JDK on Apple Silicon, because I bought the first Apple M1, the 13-inch 2020 M1 in November. I bought that first model, but then you couldn't do anything with it. I couldn't compile Java. I couldn't do graphics or editing. I couldn't do anything. It was just a nice toy, But it's only like $1,500. I didn't care. It's just I just wanted to try it out, and it was awesome. But then Microsoft, of all the companies, Microsoft was the first to have a JDK distribution that ran on Apple Silicon. So, they made Apple's platform real for Java developers. That's such a wonderful world. Yeah, it works great. It works flawlessly on this. But that's a good point. The GraalVM builds, you can't do cross compilation. So that binary I showed you is native to Mac. It only runs on Mac on Silicon. If you want to do Linux, you got to compile on a Linux box. You can do matrix builds in GitHub Actions, of course, and so you can run the same build pipeline on different operating systems. Run it on Ubuntu, run it on Linux, run it on Windows, whatever. And that's great for CLIs. If you want to distribute a CLI, you can use Spring Shell and then package up a CLI application. And you don't need the JRE. You can say mycli.exe or the mycli for Mac and Linux. And you can just package them up at the end of the pipeline and upload them to GitHub packages, whatever. There's some really interesting opportunities here. Believe it or not, I am a Kubernetes contributor. And the reason is because I wrote the Spring Boot 3 support for the Kubernetes Java client, right? So the official Kubernetes Java client has Spring Boot 3 support, and it has native image support. So now you can write a controller, an operator for Kubernetes with Spring. It's certainly a lot more elegant and fun than anything in Go, for example. So this is just great. And then it just starts up in no time at all and takes 50 megs of RAM. Yeah, that's awesome. Because you don't want to deploy a 1 gigabyte operator, right? That feels weird. It feels very wrong, especially if you've got Node.js apps and Go apps and they're all taking 50, 100 megs of RAM, and here you are taking a gig just for the operator that manages those other apps. No, GraalVM feels much better that way. Oh, if you're doing build packs, by the way, the native image, if you do build packs, even if you're on Mac, since you're using build packs, it builds in Linux. Your code gets compiled in the Linux container. So you actually get a Linux binary, even if you're compiling on Mac, which is cool. Slow, but cool. Yeah, GraalVM's great. You can compile your GraalVM stuff to DLLs, like a dilib or .so or .dll. So in theory, you could write Spring Boot app code and somehow, and I haven't tried it yet because I'm scared it would work, and then how would I live with myself? But then in theory, you could link it to your Android code or your Windows Forms code in C++ or your Rust or Go code or something. You could, as a library, you could just import it. Oh. Questions, comments, feedback, tomatoes?
So if you have a time, so online guests are a little bit more example for GraphQL? You say?
Sorry, what? Are there more examples?
Yeah, more examples.
Yeah, I did a whole YouTube series, Spring Tips GraphQL, right? And it's like 6 or 7 videos. Just look for these videos from last year, June of last year, May and June, I think. I did one a week, and there's 6 or 7 of them, or 8 of them. And it's each one's 20 minutes, and there's because remember, GraphQL doesn't care about HTTP. I'm using HTTP here, but you can use RSocket, you could use WebSocket, you could use service and event streams. It doesn't have to be an HTTP, just like SOAP doesn't care about HTTP, right? It's incidental. So there's a whole discussion around different protocols. You can run GraphQL on top of different protocols. GraphQL on top of RSocket is awesome, really, really fast, right? Reactive non-blocking GraphQL on top of a really efficient binary protocol. there's a discussion around data. Like I showed you that I created a controller and then I forwarded it to a repository. But if I have a query DSL repository, I can just automatically have that query DSL repository methods turned into fields. I don't have to write the controller that then invokes the repository, right? I can just automatically export my repository as a GraphQL endpoint. That's nice. Show that. There's a whole discussion around queries and clients, and there's a Java client, there's a GraphQL Java client as well that you can use that has different implementations for WebSockets and RSocket and HTTP. There's a discussion around security as well. Like if you want to secure a GraphQL application with Spring Security, how do you do that? There's a whole series. Spring tips. Look for, there's like parts. Does it? Yeah, I guess each blog. I think I upgraded each blog. So, well, find like Spring tips, learn Spring for GraphQL parts. I think if you found like part 8 or something, it'll have links to all the videos from the early ones.
Okay.
Do you have any sneak peek from the Spring Boot 3.2?
Yeah. Well, not on me, but one of the nice things that's coming in there is new blocking clients, right? So there's a video on my YouTube channel, Coffee Software. You can watch that if you like. And basically, just watch this. It looks at the new support of Spring Framework 6.1 and Spring Boot 3.2. And basically, there's 2 new interesting things. There's a JDBC client instead of the JDBC template. It's a fluid DSL. And there's also a REST client instead of the REST template, right? And yeah, it's like, you can watch that. I just did that 5 days ago. Yeah. And the code's github.com, Coffee Software Show, and where is it? This one, clients, you can look at that. The new fluid. It was a bit of a pain in the butt to get working because some of the stuff is using snapshots. So you'll see I spend a fair bit of time in the video just like fiddling with the build. My Gradle foo is not very good yet. There, so there's the JDBC client. Create the from that, and then there's the REST client, and it's JDBC client, REST client. And I show how to use JDBC client.sql, insert, blah, blah, blah. And also the, where's the REST client? Oh, yeah, I show you how to, remember those declarative interfaces, right? Now you can use the REST client behind the scenes for that. So there's 2 different implementations of this interface. Here's Auto Star Wars client, and that's using the declarative annotations. And then behind the scenes, it's using the new REST client. Or you can do manually, and I use the REST client here. That are directly REST client.get.uri.retrieve.toentity. All good? Any other questions?
It's okay.
Okay. Thank you, everyone. Appreciate it. Have a good night.
Thank you so much.
じゃあアナウンスを前谷さん。
あ、私？
その前に。
はい。はい。はい。私はどこに手が映るんだ、これは。すいません。自分でね、画角を見ながらって難しいんですよ。はい。映ってる？
入ってます。
はい。JJUGからのお知らせです。8月は、ナイトセミナーは久々にオフラインで LT 大会を復活させたいと思います。オフラインでみんなでバトビールを飲みながらやりたいなと思ってますので、ぜひ皆様オフラインでの日程調整をお願いしますと言いながらまだ日程が決まってないし、場所も決まってないんですけれども、明日、明後日には決めて公開していきたいと思いますので、ご参加よろしくお願いします。ネタ作っといてください。と、 あと、11月11日、ポッキーの日に JJUG CCC2023 ホールをやります。で、今回はオンラインなしで、オフラインのみで開催いたしますので、皆様、11月11日、新宿に来れるように日程調整とホテルの準備をお願いいたします。はい、その他何かアナウンスってありましたっけ？大丈夫ですか？
多分ない。
大丈夫ですかね。
はい、
はい、ありがとうございます。じゃあ、以上となります。ありがとうございました。
ありがとうございました。
配信を止めます。